So, we are now going to have a different architecture for the neural network, okay. And so, we are going to come to now a different architecture which is called the recurrent neural network. Again, I am going to spend only a few minutes or half an hour or something, but this is a big topic in itself. So, we are going to see now a different kind of a neural network, and we will see that we first got rid of the lexicon here, right. We still need a language model, and then we will see later on we can even get rid of the HMM itself and directly do things, okay. So, and then progress to even things like language modeling and all. I will come to it, okay. So, what happens in a recurrent neural network? So, how is it different from a traditional DNN, right? So, just to remind you, how does a DNN work? So, you have an input node, right, some input node, then you have some hidden layer. There can be one or two such many, or if it is a deep neural network, there are many such guys, and then you have some output node, right. So, here some decision is made, right. So, it can be softmax where I might have memory problem, I can try to classify some 10 different classes, or it can be binary, is it a cat or a dog. So, this is the input, right. So, this is the input layer. These are the hidden layer H1 and H2. So, hidden layer 1, hidden layer 2, and this is the output layer, right. So, in a feed forward we are going to go feed forward only, we are going to do like this. Similarly, we are going to go like this and so on, and finally from here it will go here, right. So, all of these will feed. If it is a single binary classification 1 or 0, you can have only one node. If it is a 10 class problem, you will have 10 nodes, and we use softmax and get a probabilistic kind of thing, okay. So, now let us say I gave one waveform here, right. Then I make a decision what sound is there, right. Another waveform I give here, another waveform I give here. Again, what will I do? I will feed it through this node, somehow I extract some features, right, and then I pass it through the same nodes, and again I do another analysis, right. So, another decision. So, again this idea of feature by feature. So, this feature does not influence the next guy, okay. So, in speech maybe this would have been the O1 vector, this might be the O2 vector, right. The decision here that I make is not, O2 is not influenced by what happened in O1, there is no, it is completely independent. O2 I make a decision separately by passing it through the network, okay. But we think we should be taking care or exploiting what happened before, because I do not say arbitrarily some sounds, no, there is some structure, right, and also there is some finite time for which I am going to speak, right. I do not say every 10 milliseconds I do not change the sound, and so smoothly I go from to n to d. So, therefore, it is important that we capture some kind of a history in the network, and for many applications this will be very useful, and that is the basic idea of a recurrent neural network, that we need to have some feedback so that we know what happened previously, which will help us better do classification now, right. Based on the history, maybe I get more information, more context, and therefore I can predict or correctly get the classification for this particular step, okay. So, that is the basic idea of a recurrent neural network. So, in a recurrent neural network, the basic idea is that if I am following a sequence of vectors, features, right, in a DNN we are not connecting them in any way, right. So, each one independently does a decision without worrying about what happened previously, right. So, that is the basic idea in a DNN, right. In a recurrent neural network, I know this came first, then this guy came, then this guy came, okay. So, for the first one I feed through and come as it is. So, let me just remove and do it only with one layer, so that you can see. So, let us have only one layer, and then the output is here, right, some kind of here. That is for the first, first MFCC vector I might be doing this. Then the next MFCC vector comes O2, and I again do find out what sound it corresponds to without worrying about what happened in O1, right. O1 is not influencing my decision. Similarly, when O3 comes, right, O3 comes, I will again give something like this, and then O3 I make a decision, okay, or I might have even multiple, maybe 2 or 3 class problems, speech versus silence or something, okay. So now what happens is, here each one is independent, there is no connection between the two, right. Each one does not depend on the other guy. So I can parallelly itself do this whole thing, okay. But what if I want to do something like this? That O1, the effect of O1, I want to pass it on to O2, right. So that some information of O1 is there for O2 also. So remember, O2 is going to go to this guy through a matrix W, right. Remember, there is a weight matrix, right. So I can, all these connections I am passing it through a weight matrix, and let us say the input is, let me call this as O2, right. So this is the O2 input, which is a vector, and this is passing through the W matrix, and then out will come my H2 output, H2, which is a vector. Then it will operate another matrix V to give me an output, right. And so this is one way we are doing it. Now in an RNN, we will always maintain the same matrix between each layer. So this guy also will go through a W matrix. So the W matrix is not changing from one guy to another, that is given, okay. And O1 now passes to this, and then I will get H1, which is a hidden output here, right. So I will get H1 here because it is the output of O1 passing through the W matrix, and then H1 will apply on the output H1, I apply the weight matrix V to get my Y1, the first output. This will be Y2, my second output, this will be Y3, my third output, okay. So till now, this is still a deep neural networks, there is no connection between them, right. Now what I do is, I take this H1, pass it through another matrix. So sorry, I should have called this as U, okay. So historically this is called U, okay. Historically this is called U. This is the U matrix, this is the U matrix, and I also now give the input of this H1, I feed it now through another weight matrix W to this guy, okay. So now this hidden node, if you look at the hidden node, if you look at this O2 hidden node, so this hidden node will be like this. There will be two inputs coming, one coming from O2, this is the O2 vector, this will feed through the U matrix. There is another input that is coming here, which is the H1, the previous guy's output H1, okay. This will be fed through a matrix W, we will add both of them and then pass to this guy, okay. And then nonlinearity will appear, and I will get H2 here at this point. So now the H2, the output here H2, because of this connection here, now there is a connection W coming, is influenced by two inputs, one coming from O2 and the other coming from the H1, the previous guy. Similarly, if I look at this guy, I am going to feed now this guy H2 also to this guy, apart from the U that is going to feed to this guy and the V that is going to feed to this guy, okay. So there are now at every step two inputs coming to the hidden node, one coming from the input at that particular time instant and one coming from the previous input, which is H2 in this case. So in this case H2 will come. So again, if you look at this guy, the hidden part of it, the hidden layer part of it, there will be O3 itself which will be providing some input, O3 itself which will be providing some input through the matrix U, okay, plus the previous H2 will also be coming here, H2 will be coming here, this is H2, this is O3, this will be feeding it through the matrix W, and together we add these two guys and feed it to the layer. So, at every layer the previous output is going to be influencing it. So, if you look at this point, right, this is called H3, this hidden guy output at the third input is going to be influenced by O3 and influenced by H2, right. So, H3 is a non-linearity of, this is the non-linearity symbol of UX3, sorry, UO3, let me write it down clearly, making a mistake here, so that you can see clearly what I am doing. So, if I look at H3, the output here, it is going to be influenced by two things. So, this guy, if I look at this guy H3, right, this H3 is going to be, first I am going to do a linear combination, which is the W matrix multiplied by the previous input H2, the previous hidden node vector, plus the U matrix applying on the O3 vector, the sum of these two, then I apply a non-linearity. Okay. So, H3 is influenced by H2 and the O3, the current input and the output from the previous time step, okay, previous 10 milliseconds back. So, H3 has now influenced by two, not only directly by the input at that particular point like a DNN, but is also influenced by what happened previously through H2, right. Now, if you look at H2 itself, it itself is going to be influenced by what? H2 itself is going to be influenced by W times H1 plus U times O2. So, if you look at H2, H2 is influenced by both the current input and the output from H1. So, H2 is influenced by H1, right, but H3 is influenced by H2 and H2 itself is influenced by H1. So, H3 now has whole history. It depends on H2, but H2 itself depends on H1. So, both H1 and okay. Now, let us look at H2. H2 is dependent on O2 also and H1. H3 is dependent on O3. So, if you look at H2, H2 depends on O2, right. So, therefore, there is O2 coming into the picture, right. Now, H2 itself depends on H1, but H1 is influenced by O1. So, if you look at H3, it is not only influenced by O3, indirectly it is influenced by O2, right, through H2 and H1, because H2 itself depends on H1 and H1 depends on O1. So, at every point the whole history, what all happened in the previous vectors are going to get captured. So, this is called recurrence relationship. So, there is this is the recurrence, right. So, I am giving a feedback from the previous output to the new input, right. So, it is getting some history captured, right. So, therefore, there is a history that is being captured. This is essentially like it has memory now, okay. It has memory of what all happened previously in its analysis, okay, and so this is a good thing, right. So, now this is the basic idea of a recurrent neural network, okay. So, this is what we are going to do. So, in a recurrent neural network, the previous guys are going to influence the new guys, okay. So, therefore, I will just briefly go through. So, this is what I have drawn here, okay. So, this is essentially what I told now, and this is the way we each input. So, it is a sequence of inputs. So, x1 is first sent, then x2. So, let me light it up. X1 is first sent, then the x2 vector, then the x3 vector, then the x4 vector and so on. Now, because x2 comes after x3, x3 comes after x1 and x2, x4 comes after x3, x2, x1, we want that history to be captured. So, this is going through the U matrix. So, the input to the hidden node is given by the U matrix, the hidden node to the output node is given by V. This is a standard kind of notation that we always use, and the connection, that is from the previous output W to the next node, I give two inputs U times Xi. So, if I am looking at the output at this S3, let us say, if I am looking at S3, I equals 3. So, S3 will be U times, so this is 1, 2, 3, this is S3, U times X3, U times X3 plus W times the output, which is S3 means S2. So, S2, and this is a bias term, do not worry about it, that is something that we always do, and the output will always depend on the if it is S2, Y2, Y3 means it depends on S3, Y4 means it depends on S4. So, that is the direct dependence. Okay. So, this recurrence comes from this cross path. Okay. So, one is going directly, and now we have a connection between each of the time from x1 to x2 there is a connection, from x2 to x3 there is a connection, from x3 to x4 there is a connection, and because the connection keeps on, I can go back and track all the way. So, x4, for example, here y4 will actually depend on x4, but indirectly also come and depend on x3, indirectly on x2, indirectly on x1. So, to get to y4 I am actually dependent on all the 4. So, the whole history has been nicely captured by a recurrent neural network. Okay. So, this is the way we plot it, but actually this whole thing we actually put it by one symbol. So, this is like one character, but then we are going to put the entire block that I had before, right. This whole thing we put as one big circle, at the bottom is one big circle and top is one big circle. That is the way we are going to operate. Okay. So, why is recurrence important? Okay, I'll come to this thing. Okay. So, let me go back. So, we see that even in speech, even for MFCC vectors, this is a very useful thing to do, correct.